Okay. So today we'll talk about this extra subject, which is not really part of the book, payment security. There is part of it that is covered in an old book, actually. And that is the first part we'll talk about today, the secure electronic transaction standard. But since that standard is not really used today, it's removed from the book, but I didn't add anything else. But I have come up with some new topics that I think is interesting in this concept of electronic or payment security. So, as I say, we'll cover quite a few things, both protocols and more products. But we'll first look again on the options we have for adding security at different layers. And we talked about quite a few different options here. We talked about the network level, and there we had IPsec, for instance. We talked about the transport level, SSL, TLS, or SSH. And we talked about at the application level. And at the application level, we typically implement things that are more specific. So, I mean, at the transport level, for instance, I mean, all different applications or standards need a transport connection in order to work on internet. So therefore, it's quite natural to put some type of security, and then it can work for anything. But at the application level, it's more specific. So here we have, for instance, the email security I talked about before, with PGP and SMIME and so on. But now we'll also talk about payment security, because that is also something that is typical at the application level. I mean, it's very application specific. If you and someone else would make some type of electronic transfer of money, that's not a general service, that is very specific. So that means that that type of security should be on the application level. So, set or secure electronic transaction. It's an open encryption and secured specification. So anyone could use it. And the idea is, as I said, to protect credit card transactions used on internet. So the typical case here is that you have some type of web shop and you are a customer of that one, and you would like to buy something on that web shop and you want to pay with a credit card. When this standard was created, that was not a typical situation that it is today. So they really had to start almost from a scratch. As you see, all the major credit card companies are involved, and that we'll see later on again, that they have merged together to create new standards over time. What it's not a payment system, so it's not meant actually to move money. It's meant to move information about credit card information, so you could then move money after that once you have that information. We'll look a little bit on that as well. So the services that SET provides then are these, as you see, a secure communication channel between the different parties that are involved here. But credit card information has to go through different levels on different links. It provides trust for certificates that we talked about before. It's using X509 certificates to gain trust, mainly from the merchant, but also for the client. And it ensures privacy. The idea is that if you buy something from a web shop, of course, you and the web shop need to know what you have bought, but no one else should need to know that. Specifically, the bank that you involved or the credit card company you involved to pay it only need to know how much you need to pay, not what you have bought. So some features here, see, confidentiality information, of course, by using encryption. Integrity of data using hash functions, of course. Cardholder account authentication. We need to prove that we are the holder of the card. And the merchant on the other side need to be able to authenticate. And both are using then certificates to do that. So this is the typical situation then, with the different participants that we have. We can start down here with an issuer. An issuer is an issuer of a credit card, so Visa, MasterCard, or something like that. We have a certificate authority, and that's the normal certificate authority we've already talked about. So they are certifying normal X59 certificates. We have a cardholder, and that is us as a normal person. We have a credit card issued by one of the issuers. We use that to connect to webshop, a merchant. And so the flow here is that the cardholder over the internet contacts the merchant to buy something. We supply the credit card information to prove that we can pay for it. The certificate authority is involved to authenticate both us as a cardholder and the merchant, so we can gain trust in each other. But then, once the payment should be done, the merchant have this payment gateway. So the payment gateway is a gateway between internet and actual systems that can move money between different accounts. So these are bank systems that are used to move money. And the payment gateway can then contact a bank. The acquirer is the bank that the merchant is using. So here the merchant have a bank account, which means that we pay with a credit card. The credit card company have to move money through this payment network to the bank account of the merchant that is at the acquirer. So the money that actually flows is here. And again, the certificate authority is involved to certify these, but the actual payment is going down here. And the information about what we're buying is going up here. So a typical sequence then of transactions, what happened here. You as a customer open an account. You get a certificate. The merchant also need their own certificate. They also need to register and get certificate from a CA. You place an order with that merchant on the web shop. You can verify the merchant using the certificate that the merchant have. Then you send what is called here order and payment. And that's the real core of this set standard, how you create and send this order and payment information. We'll look more closely at that. From that information, the merchant can now request what's called payment authorization. From that information that you send him, he can extract the information, send it to the payment gateway and ask, is this customer actually able to pay for this? So that's payment authorization. Once the payment gateway sends back to the merchant, say, yes, that customer have his credit card and it's possible to use it for this, or it can be a debit card as well. Then the merchant confirms the order to the customer and provides whatever it is. You're sending out a goods or an online service, whatever. And then only after that, the merchant again go back to the gateway and ask for actually moving money to get the payment. There are, of course, some possible weak links here in this chain. Can you see and how someone could try to do some fraud here in this setting, in this chain. The customer has a certificate. So by providing that, we of course think that the CA has checked the customer, so we know who the customer is using that certificate. That is the work of the CA, so that is really outside the standard, but it's... So we should, after this exchange, know who actually are both parties should be authorized correctly using the certificate, so we know who they are. Well, could the customer fool the merchant somehow? Or could the merchant fool the customer somehow? Well, in either case, if they do, we know who they are. So if they did something wrong, we could, after the fact, then possibly go back and say, well, you didn't live up to your part of the bargain here, because we know who it is. But the possible weak point is here, at the end here. The merchant gets this order payment information, requests payment authorization, checks that we can pay for it, and confirms the order. But what happens if the merchant doesn't do step 9 here? We never send the goods. Well, there's no verification from the system that the customer got the goods. So that means that the merchant can get payment without sending any goods, possibly. So there's no verification that we received something. But that's a minor thing, as I said, because we know who the merchant are, so we could complain. But of course, it could be, they could say, well, I did send it, and I said I didn't receive it, so there could be a conflict there. But that is possibly a limitation here. But the real strength of this protocol is this one that's called the dual signature. And this dual signature is the payment information and order information that is hashed together, as we'll see here. So we take the payment information, that is information about our credit card, then, how we would like to pay for it. That information is hashed. Both these will look more closely at exactly what they contain, but it's typically information about our credit card. We hash that into what is called this payment information message digest. Then we do the same with the order information, that is what we would like to order from merchant. Again, we take a hash of that into this order information message digest. We concatenate those two and hash it again. So now we have linked those two things together in this hash, the payment order message digest. It contains the information both about the payment and the order. And then we encrypt it. And we encrypt it, as you see, with a customer's private signature key. So we sign that payment order information digest, we can say, into what is called this dual signature. What can we do with this information? Well, since it's signed with the customer's private, we can decrypt it, getting the public key of a customer, and that should be easy to get. What that tells us is that we know who created this payment or order information, because since we could decrypt it with the public key, we know who the owner is, since we have a certificate. So we could go back to this one, and we know who created it. But of course we couldn't go back further in the chain here because these are hashes, one-way functions, so we couldn't get back from this information to the actual payment order information. So we need to know more in order to use this. So this is what goes on in the payment processing. We take the payment information, again, our credit card information, plus the dual signature that we created on the previous slide, plus the order information digest, so the hash of the order. And then we encrypt that with a session key. That session key is encrypted with the bank's public key, which means that the only one who can decrypt this information, this part here, is the bank, because it's only the bank who has the private key that can be used to first open this digital envelope to retrieve the session key and then decrypt the encrypted payment information. Okay, so that's part of a message. But then we also add the hash of the payment information plus the order information in clear text plus the dual signature again plus the cardholder certificates that is us as a customer then. This entire message is received, as you see, by the merchant. That is our payment information that we send to the merchant. What can the merchant do with that? Well, we have the order information in clear text, so we can see what the customer wants to buy. So that's not a problem. The merchant needs to know that in order to give us the goods, of course. Then we have different pieces of information here. We have a dual signature, we have his hash, and we have a digital envelope and the encrypted payment information. This part we couldn't do anything with. We don't have information to, at the merchant, we couldn't do anything with that. We don't have a key needed to decrypt it. So that's of no use for us. We do have these hashes and the dual signature, but again, that couldn't, as I said before, that couldn't help us to get back to the payment information. What the dual signature can do for us is that we can check that it was actually the cardholder that sent this message, so we can get this non-repudiation. He couldn't deny that he made this order. This part up here, the merchant couldn't know anything about, but it can pass it on to the payment gateway, who passes it on to the bank, and the bank can decrypt it, because the bank has its own private key. So the bank can see how we would like to pay for something. We don't know what it is at the bank, because we don't have this part, the order information. We only have this payment information. So the bank could see this customer wants to pay X amount of money for something. Is a cover for that at the account or a credit card. And the bank can say yes or no, and then tell the merchant. And then the merchant sends the goods and then asks the bank again, okay, now I send the goods, get me the money. So this is what the merchant typically do. The merchant checks the certificate, of course, gets it to decrypt the dual signature here. Now we know it was the customer. It can take the order information, do its own hash of it, concatenate with this payment of order information that we got, and compare these to check that this order is actually connected to this payment. And that is also an important part of the protocol here, that we link together the order with the payment. So after this, the customer have proven who we are. We told how we would like to pay, what we would like to buy and how we would like to pay for it, even if the merchant couldn't see exactly what that information is. And at the later stage, we couldn't deny because they are linked together. So we actually have that trust between the payment and the order. So it's quite nicely done. The customer gets privacy, and the merchant doesn't know anything about our credit card information using this standard, because everything of that is encrypted. Compared to the situation typically that we use today, when you go to a web shop and you give the credit card information to web shop, that means that the merchant knows about your credit card details and can misuse them. If when SET is used, that the information is never seen by the merchant at all, so they couldn't misuse that information. Well, as I said, we split up the payment into two phases, authorization and capture, but that's a minor detail. So SET has been around for quite a long time. It was implemented, but it was never widely used. And the main reason for that are these two. It was quite complex to set up. You needed all the different components to work together. So you needed different software components at the CA, the banks, the merchants, the customers. So it was a complex architecture to launch. And it required clients to have real certificates, which at that time was very unusual that users had. Today, you all probably have a client certificate already of some sort, which means that today it would have been much easier to implement SET. But at that time, it was unusual and it was a little bit expensive to get for clients. So, since SET failed in some ways, it was a very nice approach. It's some nice capability, but it didn't work. We had this instead, the 3D secure protocol, or the free domain secure protocol. In many ways, it's similar to SET. The basic idea is still the same, to protect credit card purchases on the internet. It has gone through quite a few different version numbers, as you can see here, and it has to adopt to different changes in law, apart from being a technical development as well. But it has been around for a number of years, and it is working now. So let's look a little bit on that protocol then. So the 3D stands then for, as I said, the free domain model. And the free domains that we are talking about are these. We talk about the card holder or the card domain. We talk about this acquirer or merchant domain. And then we have an intermediate domain that links them together. So these are the free domains. So as you see, the parties are very much the same as for SET. We have an issuer of credit cards, we have a card holder, we have a merchant, and we have an acquirer bank somewhere. So it's more or less the same actors, which is not surprising because those are what we have when we would like to pay for something with a credit card. So the issue domain, the acquire domain, and the interoperability domain. The protocol is an open standard. Again, it was the different credit cards, the major credit cards, what was behind it, but they developed a common standard But then they have done different implementations of it. So these are different implementations of a 3D secure protocol, verified by Visa, the Mastercard secure code, etc. So these are probably the terms that you may have seen, not the 3D secure, because that is just the standard behind it. But the verified by Visa and Mastercard secure code is the one that they're commercially promoting. So for this to work, first you need to have a credit card. And then you have to enroll that credit card into this system. You have to tell that this credit card should be protected with 3D Secure. And that requires that both a credit card company and typically you get a credit card from a bank or something like that. And that issue is also part of this 3D Secure process. So you go to an enrollment site through the internet. You provide enrollment data about your card and establish what's called, as you see, a shared secret. Typically a password, but it could be something else. The issuer then verifies that you are actually owner of this credit card, and then that information about your credit card and your shared secret is stored in a database that is available. So a called account holder file that is available on the internet. The idea is that anyone who uses or would like to, whenever you pay with your credit card, on the merchant side, they should now check against this account holder file if your card has been registered or not. So the purchase transaction looks like this then. Quite a few steps, as you can see. We have a different parts again. We have you up here with your credit card and your computer. Down here we have the credit card company. Up here we have a merchant with what's called a merchant plugin. And here we have acquire the bank system. And as before, up here over internet we send the information about the credit card and about what we would like to pay. But the actual money transfer is done down here on separate networks, the payment networks, the bank networks. So it's exactly like the set model. Here we have the dictionary, this information about cards that are, well, actually it's a combination of these two that keeps that information about which card is signed up. So the flow, well, you have the different steps here later on in the slide here, but let's very quickly go through them. You place an order of some sort. The merchant now checks against this dictionary about the status of his card. This dictionary gets back to the actual issuer of that card to check that it's a valid card and some details about it. That information goes back here and is forwarded to the merchant. So okay, now when the merchant knows that we want to pay with something using a card that is secured by 3D Secure. The next step is that we send a message back to the customer saying, okay, you have a card that is protected by 3D Secure. Now to prove that you actually are the owner of this card, you need to authenticate again with this secret that you registered before. Now the merchant doesn't know anything about that. So what happens is that that message is forwarded down to your issuer. So between the card holder and the issuer is now an exchange of information where you verify that yes, you are the person who is actually in control of his card. So that exchange the merchant never sees. The effect of that is if it works out that you could verify, then you get a token that you can send back here to the merchant that proves that you have verified. And once the merchant have that, it can send back to you, say, okay, you have been able to verify, and now we can deliver goods. There is some logging down here in the merchant plugin, and now the merchant can also ask for actual money transfer down here. So that's roughly the flow. So it's similar as before. The major thing that is changed now is that you actually give your credit card information to the merchant compared to SET, because the merchant is doing this checkup against this dictionary, so he knows to know about your credit card. So that is not private anymore. And then another difference compared to SET is that you have this exchange down here where you verify that you are the owner. So each time you use your card, you also involve the issuer here. And you probably use this, I guess. You have your credit card probably protected by 3D Secure, which means that any time you want to use it, something pops up and says, yes, now you have to verify. So a new window pops up somehow. So that's the typical way you handle it. You could verify it with a password, or you could verify it in here with bank ID in Sweden, for instance. So there are different options for it. There are some issues with 3D Secure. We have this thing that a new window or frame opens up. Because you have a contact with a merchant, and now suddenly you need to also communicate with your credit card issuer. That couldn't be done in the same window typically, so a new window or new frame pops up. That is a point that is a possible phishing attack point, because it's very hard to verify who is actually behind that new window. It's typically quite an anonymous window. You don't see anything about who is behind it. So that's an issue that is something that I have worked on in the standard to try to minimize that problem in later versions. You also have is that the mobile devices doesn't always work, because mobile devices doesn't have the same support for browser, so this pop-up windows on might not work. That is also a smaller problem today, since mobile devices are quite capable. Then we have this one. From February 2015, the European Union requires what's called strong authentication for internet payments. And at that time, 3D Secure wasn't considered to be strong, actually. And so they had to work quite a lot with that to meet EU standards for it. And it's a little bit of a question, actually, if they have, but it's tolerated by the EU, the solution they have, at least. And then the last one. Merchants are reluctant to use it since it requires an additional step. And you know that a company like Amazon, for instance, have this one-click purchase. You only click and then it's done. You don't have to, it's very quick. And here it's not that fast. You have to actually go into a new window. You have to enter, authenticate. They are reluctant to use it because they fear that it will stop some persons from actually buying things. So they would like it to be very fast and simple to use, even if it's secure, and that's quite hard. But it is in use today, and it's fairly successful, I would say. The problem is still that not everyone is using it. And even if you have enrolled a card, it may be possible to pay that card, because not all merchants checks against this directory if your card is enrolled or not, which is a weakness, because if you said that your card should be protected with that, you really want it to be protected, but you couldn't enforce that as it is. Right. PCI is another standard that has another focus, but it's related to 3D Secure, because again it's about credit card payments, or payments using different types of cards. Can be debit card or credit card and so on, but all these type of uses of cards. And that is called the payment card industry, those who are involved in this. And they have an organization that is working with security around using of payment cards. So they have set up several standards to try to ensure that all organizations that store, process, or transmit cardholder data should do that in a secure environment. So the purpose here is not focused on you as a customer. It's focused on anyone who have some type of service that means that they access information about payment cards. So any organization that handles this data, what they need to do is they need to comply with the standard. And of course, it's not a word standard. It comes from the United States. In the United States, it's mandatory. You need to live up with this standard in order to handle credit card payments. In many other countries, it's not mandatory, but it's still a good idea, because it's actually quite a useful standard. So that means that organizations also in Sweden typically live up with that, and especially an organization who would like to somehow have connection with United States, they need to comply again. And how do you comply? Well, you comply by implementing the standard and then have a company who is reviewing what you have done and checking that you actually have done it correctly. And you need annual reviews. And depending on how big your organization is, how many credit card transactions you handle each year, you have to live up to different levels of compliance here. So if you're a very small company who will handle a couple of thousand transactions per year, you don't have to show very much. But if you are at the top here handling millions of transactions, then you have to live up to the full standard. So again, we have a credit card companies behind it, and of course the idea is that try to secure information about credit card information so it's not leaked. And you have this PCI, the Payment Card Industry Security Standard Council, that is behind these standards. So the standard consists of several different protocols or substandards, but these are the main ones: the PCI DSS, the PA DSS, and the PTS. And the one that is mostly commonly referred to is this one, the PCI DSS, because that involves most organizations. But let's very briefly say the PTS one. the PIN transaction security. That is a standard that is used by manufacturers of different type of hardware that handles PIN codes. So when if you have a terminal and you enter PIN codes, they need to live up to standards to handle, so people couldn't get out that information in by eavesdropping or something like that. So that's it only affects those manufacturers of this type of equipment. Then we have the PA DSSC, the soft that targeting software developers. So if you are software developing a system that is meant to be used off the shelf for any company who would like to, say you're building a web shop system, and that web shop system also you have a plugin for credit card, and you would like to sell that product, then that software, to anyone who would set up a web shop, then you need to comply to this PA DSS when you develop that system. But the main standard is this one, the PCI DSS, the data security standards. As you see, any merchant or processor of credit card information need to live up with this. So anyone who somehow gets hold of credit card information, passes it on or stores it or whatever, they need to show that they live up to this standard. And that is quite a few who need to do that then. And if you look at that PCI DSS standard a little bit more in detail, you see it's really, as I see, best security practice. There are sound ideas on what you should do, but then they have broken it down in specific things. So as you see, we have these 6 categories that you need to live up with. You need to build and maintain a secure network, which for instance says that you need to have a firewall, and that firewall need to be maintained and updated and implement some sound policy. You need to protect cardholder data. And if you go into the details of that, it says, well, to protect them, that means that you need to have access right to access them, and the cardholder data need to be encrypted whenever not in use and so on. So they have rules for that. You need to maintain a vulnerability management program, so you have an organization and you have routines to handle different types of incidents. You have a policy for, or a program for educating users and so on. And well, it goes on. So it's really very sound rules in general for what you should think about. But if you need to live up with the standard, you need to show that you actually have implemented all of these. So let's take a break here before we start looking at money. What is money? So let's take a break here then. Let's see if I can get the stream working fully.